My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Go Cloud Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GloCloud team.
Welcome back, everyone. This is Michael Gibbs, and I'm here with Benedict and Mo for day 2 of our AWS Advanced Networking course. This is to prepare you for the ANS-C01 exam, and it's a full AWS Networking specialty course. If you haven't joined us yesterday, that's okay. You can go back and watch the day 1, the first video, and the second video. They're going to be here on YouTube for you. And today we're going to begin day 2, starting with Benedict in a few moments. I want to know that you're here. I want to know that you're awake. So if you give me a hashtag AWS Advanced Networking for me to know that you're here, I'll be thrilled to know that you are here. Also, I want to let you know that we have a tremendous number of free labs that we've created for you. Some on Amazon and some off of Amazon, actually done in our data center. And why do we do this? We want to make sure that you not only understand how to configure it on Amazon, that's the easy thing, but you actually understand what's going on under the hood. And since what cloud computing really means is you can't see what's going on in somebody else's network in a data center, we did it in our data center, or at least on an EVE-NG server, to make sure you can see the underlying network technology. So you can learn it the AWS way, you can learn it the real way, and by the combination together, you're going to get there. So go download it. It's completely free in the AWS Advanced Networking Bootcamp. And of course, in the description of this video, we've got a tremendous number of free things for you to help build your cloud architect career, cloud network architect career, enterprise architect career, AI architect career. So go download some free things. The format of today will be just like yesterday. We'll go for a few hours this morning. We'll take a 1-hour break, then we'll have a lunch, and we'll come back and we'll have another break. And like yesterday, we got pretty geeky, which was for me fun on the networking side. Mo and Benedict got extra geeky for you. I kind of loved watching them do it. Of course, you know, I love networking, so there's that. So I'm going to turn it over to Benedict. If you haven't liked the video, please give it a like. It'll signal the algorithm to send other people here so they can benefit from our free AWS Advanced Networking training. Hit the bell, share it. We put a lot of time, effort, and money into developing content like this to help those in need. So please go for it. Please get it, and please share. At this point, I'm going to give it back to Benedict, and he's going to continue the discussion on virtual private networks in the AWS cloud.
All right, thanks, Mike, and welcome again, everyone. Yesterday, we began the discussion on virtual private networks, or VPNs, if you like. And we spoke about how VPNs can provide confidentiality by encrypting data in a tunnel, right? We also mentioned that VPNs can provide integrity by hashing the data in this tunnel with a hashing algorithm, right? We spoke about how VPNs provide non-repudiation and authentication as well, because if you encrypt data with your private key, which is known only to you, then the receiver is guaranteed that that data has come from only you, because of course you're only person who has access to your private keys. Today we're going to talk about another important concept, which is availability, and how AWS provides this in the cloud. Right now, the virtual private gateway where your VPNs terminate is a highly available device, which means it is redundant. So when you set up your VPN connections from your on-premise locations or from your remote locations to the AWS cloud infrastructure, it automatically sets up 2 VPN endpoints on its end to provide this availability. So it puts these different VPN endpoints in 2 different availability zones, so that if there's a maintenance ongoing in one availability zone and that takes down that leg of the VPN connection, you still have another one available to keep your connectivity up. Right? So it's pretty important that they've taken this into consideration and built it into their solution. Now, when it comes to redundancy, right, having 2 links from the AWS end to your office or your remote location, you could either have a active passive solution, right, or active active. And in active passive, what's happening is that one link is active all the time and your traffic is flowing across that VPN connection. The other VPN connection is passive, which means it's just lying in wait and then praying that the primary link should fail so that it takes over and begins to send traffic. No, I'm just joking. But for the active VPN solution, you have traffic flowing across both VPN links from these different VPN endpoints in different availability zones at the same time. But we have to be careful, because when you have active solutions, there's the risk of having asymmetric routing. And what asymmetric routing is that traffic goes out one VPN link and then the return traffic comes back the other VPN link. And we don't want that in our routing because it could be problematic, right? But you could use your BGP to, enforce symmetric routing so that the traffic comes over one link returns via that same link at all points in time. So I'll just share my screen and show you how the virtual private gateway enforces this high availability in the cloud. So Chris, could you just share my screen briefly? All right, so you see what we have here. We have a VPC and we have a virtual private gateway where your VPN, your site-to-site VPNs will terminate, right? So when you set up your VPN connections from your corporate offices to your the cloud, it's set up 2 VPN endpoints in different availability zones, right? And then you could decide if you want to do active, passive, or active, active, right? So it's a fairly simple process. And the next diagram here, we're looking at how BGP prevents asymmetric routing. So recall, I said asymmetric routing is a situation whereby you send traffic out one link and then it comes back via the other link. We don't want that because we might get out of order packets, right? So in order to circumvent this, we can use BGP to detect that the traffic going over one particular VPN link should come back via that same VPN link and not the other. And we do this by manipulating metrics such as local preference, the weights, and the AS path. So if you look at this diagram, you see that the top link for the 172.16.0 network just has one AS path, right? Compared to the bottom link where the 10.0 network has two AS paths. So what it means that traffic for destined for the 172.16.0 network will always go via the top link because it has a shorter path, right? And then the return traffic always come back via that link. And then if we look at the metric, for example, let's assume we're using local preference, right? And the bottom link has a higher local preference for the 10.0 network, right? So it means that that link will be preferred for the 10.0 network for to and return traffic at all times. So that prevents asymmetric routing in a highly available VPN solution. What would it do without BGP? Now, if you recall, we said that the VPN and the virtual private gateway is a highly available device. So when you set up a VPN, it sets up two VPN endpoints in the cloud as opposed to one, so that if one goes offline, if you were to lose connectivity on one of them, you still have a backup VPN connection. But if you look at the other end of your remote connectivity here, you see that they have just one device. Could be a router or the firewall, where they terminate their own end of the site-to-site VPN. So could we say that this is a truly highly available solution? Chris, could you please share my screen? All right, thank you. So you can see that the AWS side of things has handled high availability by deploying two VPN endpoints, right? So that if one goes offline, the other one takes over. How about your own side of the connection? There's just one router there. And so this is a bottleneck. For a truly highly available system, you need to have two devices instead of one. So what that means is that we are going to have another router here and then connect the second VPN endpoint to this router. So that if one of the link goes offline, you still have your connectivity across the other customer premises equipment. Now, let's talk about load sharing across VPN tunnels. So many people usually get this concept wrong when we talk about load sharing, and especially for people who are not so experienced in networking. So when you talk about load sharing, the first thing that comes to mind is the load balancer, right? When it comes to load sharing of links, we do not use a load balancer to achieve this. What we use is a routing protocol to load share across both links, right? And in this case, since we are connecting to the cloud externally, we're going to be using BGP to load share across two links if we are running an active solution. So AWS allows you to load share, right? They make that possibility available for you so that you can get the best of both links, and not that one is always lying in wait for the other one to fill. So we set up load sharing essentially to prevent out of order packets, right? So what is happening here is that BGP will advertise the routes into BGP for our different subnets. And this is where your knowledge of subnetting comes into place, because you're going to be advertising a specific route, right, or routes across one link, and a less specific route across the other one, or both links. So what that means is that if you have a large subnet such as 10.0.0.0/8, and then you've done your subnetting and you've broken that subnet into smaller ones, so you also have 10.0.1.0.0/16. /16 here is the more specific route because it's contained within the larger route, the larger subnet 10.0.0.8. So what you do is that you advertise the more specific route, which is 10.1.0/16, across one link, right? And then you advertise the larger route, the 10.0/8 subnet across both links. So it's using it, the way it works is that the BGP will look for the more specific route and send traffic across that route first, right? And then if that VPN tunnel goes offline, or it's there's a problem with that connection, either from the customer side or from AWS side of things, you still have a redundant path that has the more encompassing subnet, the 10.0/8 subnet. And I'll show you the diagram to make you understand this better. So you advertise the specific routes across one VPN tunnel, and there's the summary route to be advertised across both tunnels, right? So the BGP will send the traffic across the specific routes, and then if that VPN link goes offline, there's still a redundant path, right? So we have to be careful when we're setting this up so that we prevent asymmetric routing in our solution. So I'll share my screen here to throw more light on what I've just explained. So in the diagram here, you see that we have on our on-premise side of things, we have a large subnet, right? 10.0.0/1, 10.0.0.1/15. And they've broken down this large subnet into two smaller subnets, 10.0.0/16 and then 10.1.0/16. So what it means is that these two subnets are contained within the larger subnet. Now, if I want the 10.1.0/16 traffic to flow across the top link, what I do is that I advertise that route on the top VPN connection. Now, this is a more specific route compared to the CIDR range of 10.0/15, right? So once I advertise that link up here, 10.1.0/16, I then go ahead and advertise the summary route, which is the CIDR range, right? 10.0/15 here. And it means that for traffic destined to or from the 10.1.0 network, to always use the top link, right? Now, if you take a look at the bottom link here, change my cursor. If you take a look at the bottom link here, we have the other subnet that has been added, advertised, which is 10.1, 10.0 subnet, right? oh sorry, 10.1.0 subnet. So it's been advertised here. It is a more specific route. You can see the subnet is a /16. And then the summary route, which is a /15, is also advertised here. So what it means is that traffic is always going to the 10.0.1/16 network across this link below, right? And then if this link fails, because you have a summary route up here, which is 10.0.1/15, and which contains the 10.0.1/16 here, the traffic will be routed via the top link, right? So this is how we load share across VPN tunnels using the BGP routing protocol. And then for the other side of the connection is the same thing. You advertise more specific routes across one link and advertise the less specific routes across the other link. Now, there are situations whereby you have multiple offices that need to connect to the cloud. And I know Mo spoke about using the transit gateway to achieve that yesterday. So there's another solution available to help you achieve this hub and spoke look and feel. And it's what we call the CloudHub. So CloudHub is an AWS solution that allows you to enable multi-site VPNs, right? So what happens is that CloudHub is actually working with the virtual private gateway. So you're going to have connections from your different locations to the virtual private gateway, right? And then you have eBGP advertising your routes from these different locations to the virtual private gateway, and then advertising those routes to other connected locations. So in this sense, the CloudHub is transitive because it allows one branch office to reach the other one via these eBGP advertisements, right? So essentially, it's the virtual gateway that works with CloudHub and enables you to, share routing information from branch locations to the other. So I'll just share my diagram here so you can see what I'm talking about. Could you share, please? Yeah. So we have a VPC here, and then you have your branch locations on the right, right? So these locations connect to the virtual private gateway via a VPN tunnel, and then they use eBGP to advertise their route. So if you have this is a 10.0 network here, and then 192.168. I thought my handwriting would be better than Mo, but it seems I'm struggling here. But you get what I mean. And then you have 172.16 network here. You're going to be advertising this route into the BGP, and then these routes will be shared across your infrastructure so that all branches can reach it and reach your VPC as well, right? So you have to take care not to have overlapping subnets, right? Because that could provide a problem here. I mean, if you had the solution such as the transit VPC that where you could do nothing, then you could get away with that. But here, you want to make sure that your subnets are unique across the branches so that there's no routing problem. Now let's talk about how to set up a VPN in AWS. It's a fairly simple process, especially when you compare it to a solution like the Direct Connect or your private line. So in order to set up a VPN in AWS, the first thing you have to do is to determine the AWS virtual private gateway you're going to connect to. So you have to go to your VPC and then set up a virtual private gateway, right? So it's a fairly simple process. Just set it up, give it an ASN number, and you're good to go. Then you choose a routing method that you're going to use for your VPN connectivity. And there are generally two methods, using static routes or dynamic routes. So using static routes is probably simpler and not so experienced engineers will go for this option, right? So if you just want something very basic, yeah, you can use your static routes and you're good to go. Now, if you want to use dynamic routing for your VPN connectivity, it's going to be BGP, which is a little more complex. So has to be an experienced cloud engineer or network engineer making these configurations. So after you've chosen your routing method, you then go to your tunnel configurations. And AWS has some default tunnel configurations. So when we talk about tunnel configurations, we're talking of things like the encryption algorithm, AES-256, and the likes. Talking about the hashing algorithm, SHA, and the likes. So AWS has a default one you could use. You could also customize it based on your wants. So many organizations would have a defined policy saying you should always use maybe AES-256, SHA-128, for example, for your VPN connections. So in that case, if the AWS defaults did not meet that criteria, then you can go in and make your custom tunnel configurations. So after you do these configurations on the cloud, right, the virtual private gateway will be automatically configured based on these parameters, right? The AWS console, management console, will also auto create a configuration guide for your endpoint device. So you could say use this configuration on your device if it's a Cisco router or firewall, or use this particular one if it's a Sophos or FortiGate firewall or Palo Alto firewall. So it has that support for different vendors just to make your setup fairly easy to accomplish. Now, when it comes to monitoring of VPN traffic, you could use CloudWatch, right, to monitor your VPN traffic. Monitor your VPN tunnels so you know when they go up and down, and see bandwidth, usage, and stuff like that. You could also monitor from your on-premise end or from your remote end, in this case. And usually that will be the dashboard on your firewall or your SIM solution if you want, right? So these are different ways that we can monitor VPN connectivity from remote locations to the cloud. And it's important that you monitor VPN connectivity because every now and then, especially if you have budget constraints, you have issues with bandwidth usage in an organization. So at some point in time, people will complain that the VPN is slow. At some other points, it's fine. So monitoring the VPN can indicate when there's more usage across the VPN tunnels and then point you towards the right direction into solving such problems. Now, we've spoken about the VPN solution in AWS. Is it possible to have a custom VPN solution in AWS? Yes, it is. So you could have your organization say that the only acceptable VPN solution is the one on the Palo Alto firewall. We're not going to use any other one, right? Or your Cisco firewall, whether it's on the cloud or is on-prem. That's our standard. So AWS has the capability for you to customize your VPN. And what it means is that you go to the marketplace, the AWS marketplace, to look for a VPN solution of your choice, right? So, for example, if I want to deploy a VPN solution on the FortiGate firewall, I'll just go to the marketplace in AWS and search for the VPN, the FortiGate firewall, and then deploy that firewall in my infrastructure, and then terminate my VPN connections there. So it essentially becomes a VPN concentrator, right? And how this works is that it's actually a virtual machine in the cloud where the VPN software is installed on. So the FortiGate firewall is basically virtualized in the cloud, right? So it's an EC2 instance that has FortiGate operating system running on it, right? And you could do that for Palo Alto, Cisco, and a whole lot of other vendors, right? So you have that capability to customize your VPN solutions in the cloud. So you have to take note that when you are going in this direction, there will be license requirements from the vendor you're patronizing, right? And so you have to be ready to take care of all of this and pay the required license and subscription fees. Now let's talk about remote access VPN, which is popularly called client VPN in AWS and in some on-premise locations as well. So you can set up your VPNs to allow individuals remotely connect to your AWS infrastructure. So now we're not talking about remote offices connecting, right? And that will be a site-to-site VPN, or remote partners connecting to your VPCs. We're talking about individuals connecting, okay? And it's very similar to the way it's done on-prem, right? So you have a VPN concentrator, could be a server, could be a router, could be a firewall, could be any device where you can just run that VPN software and then allow end users connect remotely. AWS allows remote access users to connect directly to it, but it does not use the virtual private gateway to achieve this. I mean, in the case of a site-to-site VPN, it uses the virtual private gateway to terminate those VPN connections, but it's quite different from remote access VPN. So to do this, like I said, you need a VPN concentrator in your AWS VPC. Could be a router or a firewall or a Windows server running Windows or Linux server running OpenVPN software that allows remote VPN connection. So there are quite a number of variety here when it comes to deploying remote access VPN in AWS. So if you look at the diagram here, you see how remote VPN differs from the site-to-site VPN. So you have your remote users here connecting directly to an instance in your cloud in your AWS infrastructure that is running that VPN software, right? You can see that there's no virtual private gateway in this diagram because the remote access VPNs do not work with the virtual private gateway. You just have your VPN concentrator. In this case, is a EC2 instance running a VPN software in the VPC, and then from this instance, you can now grant access to other resources within your VPC. So this is how the remote access VPNs work. Yep. So we're done with VPNs now. And we want to talk about direct connections to the cloud, right? So yesterday we looked at some disadvantages with running VPNs or establishing VPN connections to the cloud. And one of the disadvantages we discussed was the inconsistencies of the internet. So if you have a 1 gig link in your office, right, and you are connecting to AWS over a site-to-site VPN, there are certain times in the month where they need to patch Windows PCs and Windows servers. I think Microsoft releases Windows Update every second Tuesday of the month. So there will be a process in place to patch all Windows PCs just to keep them secure at the endpoint level. So you'll find that in some organizations, if there's a constraint in bandwidth, right, during the time of patching PCs, for example, your site-to-site VPN to the AWS cloud will become slow. And so if someone is trying to copy a file to object storage at that same time, it begins to complain of slowness. It begins to see things like 48 hours left. The direct connection provides a solution for that, right? It's a guaranteed bandwidth link. So it's a dedicated link. It's a dedicated link, right? And before we really delve deeper into direct connection and how it works, I'd like to see if you have any questions on high availability VPNs that we just discussed about.
Welcome back, everyone. So Benedict talked about VPNs. He talked about some high availability VPNs. Starting to get into direct connections, which is something we're going to talk about next. But does anybody have any questions? From Tariq, why not use BGP attributes other than wait or local preference or AS path prepending to differentiate an active path versus a passive path? So there's a lot of ways we could do this, Tariq. We could have a more specific route on each side that we prefer to use and leak an aggregate route on both sides. We could modify the wait. We could AS path prepend. We could change the multi-exit discriminator. We could change the origin code. We could do a lot of things. So it really is about what is it we want to do and why are we doing it? AS path, is going to traverse, but other ASs, but wait is local and local preference is local. So we have to think about what we're trying to do, why we're trying to do it, and whether we're trying to influence others or basically influence our own decision. and then we make a choice. But we could use a lot of different options here. That was just one we chose. Who else?
Sammy says, how would you load share between two links when you have more than two subnets in your data center using BGP route summarization? Well, you can advertise 20 subnets in your BGP advertisements. It's not limited to two subnets when you're advertising. So that will work.
Absolutely. So let's assume, in your data center, you've got 1,000 subnets. Yeah, you can do a couple things. One is you can't send all 1,000 to AWS. You could keep it in your IGP. But as Benedict said, you could create two supernets and then an aggregate route for all of it and send one supernet for a certain number of subnets on one link and another supernet for another set of subnets on that link. Or you could tune it and leak one specific thing. So lots of opportunities here, Sammy. Who else? Do we have any other questions there?
So Town Scott is asking, can the EC2 instances for the VPN concentrator be scaled? So you're asking about now, is this vertical scaling or horizontal? Generally speaking, when you have a customized VPN concentrator, such as a FortiGate firewall or Palo Alto firewall, right? When you're setting it up, you have the ability to choose whatever requirements you want to deploy for this particular situation, and then it's because it's a customized solution. There's a limit to the flexibility of what you can do on this EC2 instance. Remember, you're subscribing to a FortiGate or a Palo Alto solution, and it's not you're not dealing with an EC2 instance that you have created on your own. So there's that limitation there.
Right. So we can play with the size of the instances, and they're all limited. For example, there's actually one provider of virtual firewalls and VPN concentrators, a major provider, that is a single-threaded application, so it can only run on a core. So even if we wanted to put it on the system with 128 cores, we can only use the single core anyway. And that type of application does better with higher CPU frequencies. But yeah, there's options, but it's limited, as Benedict was describing. Good questions.
So Felix is asking, you mentioned you set up two tunnels, right? Can you configure one with IPsec and the other with another protocol? Or is IPsec the most secure standard? Yeah, I mean, you could play around with these things, right? But generally speaking, you want to use IP security for your VPN connections because it's just the standard, right? It's been tested and trusted. So why would you want to use another standard?
Yeah, and there's basically your TLS option and your IPsec option. There's slight enhancement, and generally speaking, IPsec's a little bit more secure than TLS, even though they're both fairly secure. So why wouldn't you use the protocol that was perfectly designed for it? Unless you need some other kind of things, you could always generate your own kind of encryption for specific needs.
So does the virtual private gateway have the VPN concentrator functionality? Can you name some VPN concentrators? So remember I said that when you have your remote access VPNs, they do not work with the virtual private gateway, right? So it's your site-to-site VPNs that work with the virtual private gateway. So let's put that in perspective. Can I name some VPN concentrators? I'll name some solutions. You have FortiGate VPN, Cisco VPN, Palo Alto VPN, Open VPN. These are some VPN concentrators you can use.
Yeah, and if I understand it correctly, does the virtual gateway have a VPN concentrator functionality? It's a virtual VPN concentrator. So anytime you need to connect to a device to terminate your VPN, it's typically a VPN concentrator. But whether it's physical, whether it's virtual, kind of very similar in essence, the same thing.
Okay. Tariq is asking, can we use FQDN instead of IP on the client side for setting up a VPN on AWS? I remember AWS didn't have support for FQDN in the past. Not sure if it has changed recently. So if you're having an FQDN on your side of things, it means that you're going to create a DNS record in a global DNS record for that FQDN, so that the AWS side can reach that record on the internet. If there's no DNS record available, then FQDN will not work on the client side. So you have to keep that in at the back of your mind. Yeah, I think it supports it now. Mm-hmm. Name not found says, when you use two VPN connections for redundancy, why do you use only one tunnel of each as shown in drawing? So I talked about the problem of asymmetric routing, right? And that's a situation whereby you have two links going to a particular location. And then when you send traffic over one link, the return traffic comes back the other link. Now, we don't want that. We want a situation whereby you send traffic over one link and then the traffic comes back that same link. So it prevents out of other packets. So I was just illustrating the different connectivity types we have. If you're running an active solution, then you can send traffic out both links and then use BGP to prevent asymmetric routing. But if you're running a passive and active solution, you always want to run the traffic across one of the VPN links.
And name not found, there's another reason why this is different on a direct connection than a VPN. In a direct connection, if I buy two 10 gig links to AWS, I'm paying for 20 gigs. And in many cases, I'm going to want to load share on those two links to get my money's worth for these two 10 gig links that I'm buying. When we're dealing with a VPN, let's say we have a 10 gig link to the internet. No matter how many tunnels we were to create to try to load share through that 10 gigs, we can never get more than 10 gigs because that's our max internet connection. So if the direct connection, it's going to make sense to load share. But on a VPN, in most architectures, it's not going to make sense to load share because not only do we have the asymmetric routing we have to deal with, but it's not like we're going to get more throughput by taking a pipe and dividing it into two halves. It's the same pipe. And we can never go faster than the speed ultimately offered by the initial internet link on a VPN. I hope that makes sense.
Sammy is asking, you mentioned that you can supernet multiple subnets and advertise them on a link, but don't you also need to send a specific subnet on one link?
I think I
You
know
want to
where.
take that?
Yeah, I think I know where Sammy's lost because I know Sammy real well. So Sammy, let's say I have the 172.16.0.0.12. That's my CIDR range. I can take a 172.16.0.0/13 and pop it on one link. And I can take the second half of that and pop it on the other link. So supernetting is just, and summarization is, how big do we want to summarize it? I can take two things and summarize it into one. I can take four things and summarize it into one, or have two medium-sized things. I can take 8 things and create two supernets that are 4 and 4, or I can create 8 links and create one supernet that's just one. So we're just talking about using a less big supernet.
Okay, I think that was the last question for now. So we can go back to the content now. Chris? Okay, so we started talking about the direct connection and what exactly is a direct connection, right? So a direct connection is basically a dedicated link from your on-premise location to the cloud. All right. And what advantage does this have? It gives you guaranteed bandwidth. So you don't have any congestion issues because you're not, I mean, congestion in the sense that you're not sharing the link with other users. Like, for example, in that scenario I presented earlier, Windows patches, right? It's just dedicated for connectivity to the AWS cloud. And here you have consistent latency. And latency is that feature that you can use to measure the speed of your link. So if you were to go to your command prompt and then ping a website, a random website, you can see the statistics that tells you the latency of your link, right? So because there's a dedicated link, you have a consistent latency on this link, and it's very reliable, right? Because it's not dependent on the internet. Now, is it possible to connect multiple direct connections? Because direct connections are usually in the 1 gigs and 10 gigs range. So if you wanted to connect, establish a direct connection to the cloud, it will either be a 1 gig link or a 10 gig link, right? But there's situations whereby the organization needs a 5 gig link or a 4 gig link. What can you do in such a situation? You could create a link aggregation group. And what that means is that you take a couple of direct connections and bundle them into one logical wire, right? So AWS supports up to 4 links per group. Now there are some terminologies that you often hear when you're discussing direct connection. One of that is the fiber optic connection, right? So I think Mike touched on it a little yesterday, where he described how direct connection works. So from your organization, you go to a colocation center, and there's a cross connect from the customer router to the AWS router. And usually the cross connect will be a fiber optic connection, right? So fiber optic connection here, because they usually provide faster connectivity when compared to copper copper connections, right? So it's one of the underlying technologies for direct connections, fiber optic connection. And it means that the customer router in the colocation center will need to have a fiber optic port, right? So the ports for fiber connections are different from copper connections, right? So generally, copper connections will be ports will be called RJ45 ports or stuff like that. Fiber optic ports will be called SFP ports. So not all routers have that functionality. So you want to look out for SFP ports when you are talking about direct connections, so that you can have that fiber optic cable run from the customer equipment to AWS router or multi-layer switch. And usually we have different types of connectors. So a connector for a fiber cable is called an SFP module, right? And earlier we mentioned that direct connection links could be either 1 gig links or 10 gig links. So it means that if you are going to connect a 1 gig direct connection link to AWS, you need a 1 gig SFP module, right? Or a 1 gig fiber connector module, right? If you're going to set up a 10 gig link between your organization and AWS, you need a 10 gig SFP module, usually called 10 gig base long range and stuff like that. Now, when it comes to fiber, there's usually a send and receive. There are usually send and receive lasers in the fiber connectivity. Of course, you know fiber is designed to transfer data using light, right? So it's generally faster than traditional copper that sends the data over the wire, right? So you have lasers going in two directions. One is send and one is receive, right? Now, if I don't know if you've ever worked with someone who's installing a fiber, who is installing a fiber link. So one person will stand at the other end of the fiber link, and then it will shine a light, right? And then the other person at the other end will tell if he can see the light or not. So that in this case will be a send laser. And then when he confirms conductivity on the side, then the return process will happen. The other person will shine his light and then ask his colleague at the other end to confirm that he can see the light. So once you have the send and receive lasers working, then the fiber channel is through and up. If you can send from one end of the fiber link to the other one, but you can't receive the laser from the other end to the primary end, it means that there's a problem and the fiber would not work, right? So it's possible that one end of the fiber link is up and the other end is not up. AWS has what we call the bidirectional forwarding detection, right? Which can help you detect whether there are problems in your send and receive lasers. Now, we also touched a bit on VLANs yesterday and talked about trunking and tagging. So at the colocation center, let's say you have a vendor like like Bell in Canada, right? They'll have a switch in their data center, and then you have 10 organizations that have requested from Bell direct connections. These 10 organizations are going to plug into the Bell switch in the colocation center. How then does Bell differentiate the traffic coming from company A to company B? It does this using tags. So it tags the traffic from each organization and then sends it over a trunk link. So when the return traffic is coming, the tag is still there. And then traffic destined for each location does not get lost, but is able to get to its location. So that's on the line technology that is used in direct connections as well. So I'll just show you a little diagram here that basically shows you how the direct connection setup looks like, right? So on the left here, you have your organization, and then it will connect to the AWS infrastructure via a direct connection or a private link. Remember, this is the internet here, right? This traffic does not go via the internet to AWS. It goes via a private link to your AWS infrastructure, right? So it terminates here, and then from there you can reach your resources in the AWS cloud. So what really happens when you are purchasing a direct connection to the cloud? Now, direct connection locations are like point of presence, like I mentioned, the colocation center. So you have a building, and then you have service providers there. You have Bell, you have Rogers, you have Telus. These are service providers in Canada, and all of them have probably dark fiber connectivity to this house, and then they have your switches and routers there, and then you also have AWS infrastructure coming into this points of presence or colocation facility, right? So once you need to have a direct connection to AWS, you probably need to get a letter of authorization, which we'll talk about later on first, and that's like authorization from AWS to the service provider, in this case Bell, the Rogers, and Telus and the likes, to establish a direct connection. So what it means is it's giving authority to those vendors to connect that cross connect cable from their equipment to AWS equipment to allow your connectivity. So from there, the traffic is backhauled over the AWS backbone network with a guaranteed bandwidth. I'll just show you a little diagram here of what direct connection location would look like. So here you have on the right your on-premise location, and then you have the direct connect location here, the point of presence or the colocation facility. So like I said, you have the service provider equipment here, and then you have AWS equipment here. And then when you get that letter of authorization, the service provider would tell you connect to port 2 of our router in your data center for direct connection to AWS, and then that connection will be taken from the router here, and then you have a cross connect from the service provider's equipment to the AWS equipment. So that's how it works in a nutshell. Once it gets to the AWS router or switch, it's routed through the AWS backbone to the cloud. So you see that this traffic does not traverse the internet, and so you don't have that bandwidth bottleneck and inconsistency of the VPN connections. So now let's talk about a letter of authorization. And what does it mean? It's basically authorization to establish a direct connection from your office location to AWS. So in order to get a letter of authorization, right, you generally will have to go to your AWS management console and then make an application for it, right? So once AWS looks at your application and approves it, you can download this letter of authorization and then share it with your service provider. So if, for example, my service provider is Bell, right, and I've decided I want to use the Bell to establish this direct connection to the cloud. I'll go to my management console, go to the letter of authorization, make an application, and then when AWS approves it, I'll download this letter of authorization and hand it over to Bell, my service provider, and say, I have authorization to set up a direct connection between my organization and AWS, right? So that will give Bell, in this case, the authority to connect a cross cable from their equipment to AWS equipment in the direct connection location, or the point of presence, as it were. So you need a letter of authorization in order to be able to establish a direct connection from your office to the cloud. You do not need a letter of authorization if you were trying to set up a VPN between your office and the cloud. So that's one of the advantages of VPN connections over direct connections. You can set it up in minutes. It's usually faster than direct connection. So you have this. So you keep that at the back of your mind. Now, I mentioned earlier that the direct connection links between your office and AWS are available in 1 gig and 10 gig ranges. Now, you could have a company that does not need that capacity, right? Because ideally, a 1 gig link, a 10 gig link is going to be more expensive than a 1 gig link, right? So you might have an organization scratching their head and saying, why do I need to pay for a 1 gig link when I just need a 100 Mbps link, direct connection link to the cloud, but I don't want to use VPN. I need something guaranteed. Now, here steps in AWS direct connection or direct connect partners, right? So if you find yourself in that situation, you need to establish a direct connect to the cloud, but you don't need 1 gig capacity or you don't need 10 gig capacity, right? You just need 100 Mbps. You could go to a direct connect partner and say, I just need 100 Mbps link to direct connect link to AWS. And they because they're partners with AWS, they would make provisions to connect you to AWS using a direct connection. So what they're going to do is that they'll connect you to a certain port on their infrastructure, and then rate limits that port to 100 Mbps. So you can't push more than 100 Mbps of traffic on that port, right? And then it connects you to the AWS backbone. So usually it will be more expensive. Like when you try to break down a 1 gig link, right, and compare it to a 100 Mbps link, right? But it gives you that value of not paying for the full 1 gig link and still having a direct connection or a private link, a private line to AWS. So they just trunk your traffic on the VLAN on that port you're connecting to in their infrastructure, and then send the traffic over a trunk link to AWS to keep your traffic segregated from other customers. Now, when it comes to direct connections to AWS from your organization to AWS, you have two options when you're terminating your direct connections to the cloud. Now, if your aim is to connect to AWS public services, right, in the region where the direct connection is established, you need what we call a public virtual interface, right? So you're going to be terminating that one end of the direct connection in your AWS infrastructure on a public virtual interface. And that this will give you access to AWS public services such as the S3, the SQS, and public endpoints. But for this to be achievable, you need a public IP on your own end of the direct connection, right? So you can have a private IP on your end of connection and then a public IP on the AWS end of the connection. It has to be publicly routable IP addresses on both ends, and then you just advertise your routes from your data center from your office location to AWS, and advertise the routes from AWS to your office location. So it's a limited BGP implementation so that your AWS does not become a a global routing transit for the internet, right? Now, AWS would not normally accept more than 1,000 routes from the customer, so you have to keep that at the back of your mind. Now, what if you want to just access your private infrastructure in the cloud, your VPC, your virtual machines, right, in the cloud? Do you need a public virtual interface in this case? Nope. You need a private virtual interface in this case. So what that means is that on the AWS end of the direct connections, you terminate it using a private virtual interface. While on your own end of the direct connect, you can assign a private IP address as well. So you see that if you want to access just the private stuff on your infrastructure, you use your private virtual interfaces. And if you want to access public services on AWS, that's when you need to use a public virtual interface. So that's basically the difference between both. So a private virtual interface is typically used to connect to the virtual private gateway, right? And then you can advertise your routes. You can advertise up to 100 routes over the BGP peering session. So in this case, you have your VPCs pairing with your virtual gateways, right, using BGP, and then you have your office location connecting to that virtual gateway using a private IP address, right? So you have to, plan your IP addressing properly so that you don't have some overlapping subnets anywhere. Now let's talk about the direct connect gateway. Now, a direct connect gateway allows you to, aggregate connections from from multiple virtual gateways, and to connect it to a private virtual interface. So in this case, let's say you have two VPCs, right, in two different regions, and they have virtual gateways, right? These two different VPCs have virtual gateways, but you want your direct connect to be able to reach these two different VPCs, even though they have two different virtual gateways, right? So it's like a point to multi-point, right, connection. What you can use here is the direct connect gateway. So you terminate your direct connection private virtual interface on the direct connect gateway, and then from your VPC, you pair you do the VPN connection from your virtual private gateway to the direct connect gateway. So that way, your office is able to reach both VPCs, right? Even if they have different virtual gateways, and then from your VPCs, you can reach your office at the same time. So you can use your direct connect to connect it to your multiple VPCs, even if they're in different availability zones and regions. So it's quite flexible in that regard. The diagram here shows you how the direct connect gateway functions in the light of what I just discussed. So on the left hand side of this diagram, you have your data center, and then it has established a direct connect with your with the AWS infrastructure using a point of presence location, or if you like, a collocation location. So you have a cross connect from the provider to AWS and then onto the AWS backbone. So you have the direct connection gateway here. You terminate your connection from your office location to the direct connect gateway using a private virtual interface. Remember what we talked about, the private and the public virtual interface. Assuming these were public services such as S3, to be terminated on a public virtual interface. And then you have your VPCs in different regions, EU West 1, East, South. And then you have the virtual private gateways from these different regions terminating on the direct connect gateway. So you see the direct connect gateway is aggregating these connections from your different VPCs so that your office can reach all of them, right? If the direct connect gateway were not available, it means that you need 3 direct connects to these different VPCs, right? And which is more cost. So AWS has helped you with some cost savings here. Now we talked about designing a highly available solution for your VPN, right? So that instead of having one VPN connection, you have 2. Now, it's also possible to have a highly available system when using direct connect. And what that means basically is that you're not using one direct connect to AWS, you're using 2, right? Or more, typically 2, right? So now there are different models, and it will usually be driven by the business requirements of the organization. So if an organization needed a direct connection to the cloud, right, and they wanted a backup solution which was not as solid as a direct connect, right, you could have an architecture that has a direct connect to the cloud, and for backup purposes use a VPN connection to the cloud, right? So if that direct connect link were to go down for any reason, right, and there could be a couple of reasons, especially from the customer end, your router going offline or stuff like that, or there's a fiber cut on the infrastructure of the service provider providing that direct connect, right? If that were to happen, you have a backup solution in place. It's not as solid. The VPN backup solution is not as solid as direct connect, but it's a solution available to help you meet your business continuity requirements. So what would that look like, right? I have a diagram here to show you what it means. All right, so in our diagram here, you have the corporate organization, right? And it has its primary link, which is a direct connect, right? To the cloud. and then it has a backup link underneath, which is the VPN, right, to the same infrastructure. You can see that we've terminated both links on different gateways here. So if this were to fail, traffic is now routed through the VPN connection, right? If either were to fail, traffic is routed through the redundant path. So this is one model we can employ when building our high availability architecture from our on-premise locations to the cloud. Now, it's also possible that you come across organizations that are sensitive, right? So they tell you, we just want a direct connection. We just want a dedicated link to the cloud. We can't deal with the inconsistency of the internet for cloud connectivity. We can't deal with VPN connection, even if it's a backup link. We can't deal with that. In fact, it's not in our security policy that we use VPN connections to the cloud. It has to be a direct connection. There's a solution for that as well. In this case, your primary and backup links are direct connections, private lines, right? Now, you have to be smart about this. If Bell was my primary service provider, would I tell them I need 2 direct connections to AWS? 2 separate direct connections to AWS, so that if one goes offline, the other one is online, right? And the availability of my operations is guaranteed. What if Bell has a major disaster and then their whole infrastructure crashes? It means that both links would go offline, right? That is not a truly highly available situations. So when you're thinking of building high availability with 2 direct connection links, you're typically thinking of 2 different service providers, right? Bell and Rogers, for example. And then you make sure that they do not their backbones are not running through the same path, right? So I mean, if Bell is coming in from the east end of the building, Rogers should be coming in from the west end. So that way, if there's a fiber cut on all the fiber infrastructure coming from the east end, the Rogers is not affected. So those are some of the things we need to keep at the back of the mind. So if we want to build that solution, right, for the direct connect, it will look like something like this. I'm sharing my screen now. So you have from your on-premise locations, you now have 2 direct links to AWS, right? You have one Bell and one Rogers. And then if Bell goes offline, traffic goes through Rogers. Or that's if you're running an active passive architecture, all right, solution. If you're running active, then traffic will be flowing across both direct connections, and then you use BGP to prevent asymmetric routing. So keep that at the back of your mind. Now, is this a truly redundant solution? Remember, we said that to have a truly redundant solution, you can't use one device. You have to use more than one, right? So if you look at this here, we have the direct connections terminating on a virtual gateway, and probably here you have direct connections on a router. To have a truly redundant solution, you need to have 2 separate routers This will be the Rogers routers, terminating the direct connection from Rogers. And this will be the Bell router, terminating the direct connection from Dell to the cloud, right? It could be direct connections across both link, or it could be a VPN connect backup link from one location to the other. So you have that redundancy here. There's a failure on this device. This device is still up and running, and then you're truly able to secure availability for your organization. So kind of keep that at the back of your mind. Now, recall that I said we can also load share across direct connection links. So if you have an active architecture where you want to utilize both direct connection links at the same time, you could have load sharing across these two links. And what this means is that, recall we said we use a routing protocol to load share across two links. So in this case, we're going to use BGP to load share across both redundant direct connection links. We also talked about the risk of asymmetric routing. So traffic going out one of the direct connection links and coming out through the other. BGP handles this using the earlier methods we spoke about, aggregation, route summarization, and the likes. So if I share my screen here, you see what I'm trying to talk about. So here you have two direct connection links, one on top and one underneath, right? And then if you're running an active solution, you just advertise the more specific routes across one link. You advertise the summary route also across that link. Then you take another specific route and advertise it on the other link, and then take the more specific route and advertise it here as well. So traffic for this route is always sent across the first direct connection link, and traffic for this subnet is always sent across the second direct connection link. So this is how we achieve load sharing across redundant direct connection links. And this if you're running an active solution, right? Now let's talk about link aggregation. If you recall, I gave a scenario earlier when I said a company might need a 4 gig link to AWS, and direct connection link comes in 1 gig and 10 gig. Now the next best solution for such a company is to subscribe for a 10 gig link, which is much more expensive than what it needs. Now, is it possible to save some cost for the organization here? We use what we call link aggregation groups to achieve this. So you can bundle up to 4 direct connection links, right? In this situation, the company needs a 4 gig link. So what it does is it reaches out to its service provider, gets the letter of authorization, and says, I need 4 1 gig direct connect links to the cloud, right? And when the service provider provides this, it then bundles these 4 links into one logical 4 gig link to the cloud. So physically, it has 4 1 gig links, right? But logically, it has a 4 gig link to the cloud. So that saves you going to buy a 10 gig link when you just need a 4 gig direct connection link to the cloud, right? How about a company that needs a 30 gig link to the cloud. Remember, we said AWS Direct Connect links comes in 1 gig and 10 gig ranges. So in that case, in that case, they would tell their service provider that they need 3 10 gig links in order to be able to achieve this 30 gig link requirement from the office to the cloud. So once the provider provides this 10 gig links, then it bundles the 10 gig links and it gets a 30 gig connection to the cloud. Now, the good thing about link aggregation is that it provides some sort of fault tolerance. So if there's a failure on one of those links to the cloud, for example, you have a 30 gig link which is bundled, 3 individual 10 gig links. So there's a failure on one of the 10 gig links for whatever purpose, for whatever reason, you still have 20 gig, right, between your organization and the cloud. So there's that fault tolerance there, which could be an advantage to an organization. So what does this look like? Let's see if I can get you a diagram. So share my screen now to show you what this looks like, right? So in this scenario, this company needs a 20 gig link, direct connect link to the cloud, right? But it's also taking care of availability. So it says I need 2 pairs of 20 gig links to the cloud. So it's going to get 4 10 gig links from the service provider. Each gig is 10 gig. So it bundles the first 2 links and it gets a total of 20 gig. All right. It is connected to one router. And then it bundles another set of 20 gig links here. It bundles another set of 10 gig links here to get a total of 20 gigs, right? So you have 2 pairs of 20 gig redundant connections. So you have this kind of flexibility when you are working with direct connections. So I'll pause here now and get some questions, if there are any, from the community.
I was trying to respond to somebody in the chat box. Bear with us. So, welcome back, everyone. Benedict covered a lot about VPNs this morning, around direct connections. I actually enjoyed watching it, even though I'm very familiar with these. So it was really great to see him do it. So at this point, let's bring in some questions that you have. And I will also address the RGB Tech one as well. We'll get there and talk about that and what it means in context for you. So bring us your questions, and if you want a little more on a direct connection, we can also, whiteboard it out. I kind of like to whiteboard the direct connection should you need anything. But let's get to the questions.
Okay, so Samson is asking, you showed VPN instead of direct connect to the direct connection location for the secondary link. Is that correct? I thought anything going into direct connection location must be direct connect and not VPN. Yeah, you're right. So for a direct connection, you need to terminate that connection in the point of presence or direct connection location. For the VPN connection, it does not go to a direct connection location. It goes directly to the internet.
I think what you did is inadvertently had a slide which we used for BGP illustration purposes, not to actually be looked at that deeply, and that's where I think he came from. That's what I was trying to put in the chat box.
Oh, okay. Yeah.
RGB Tech, is this entry level like the Net Plus? So RGB tech, I'm going to explain this since I've been training network engineers and architects for about 25 years now. The Net Plus, I typically tell people to skip. It's a good certification, but it's kind of like an intro to entry-level networking. I typically tell people to skip the Net Plus and take the CCNA as kind of their intro to networking, something like this, and then ultimately get a CCNP. And at that point, you kind of have the skills in most cases to actually do networking. So yes, this is a cross between intro level and medium level. That's the way I would look at it. But if you can learn this and anything that you don't know, you can go look up. And you can do that in maybe a CCNA and use the CompTIA Net Plus if you want along the same time as extra reference material. I think you'll do great. How about you guys?
No, I agree. I'm honestly, I'm not very familiar with Network Plus, so I can't make a comparison there. But from my understanding, Network Plus is a very, very entry level. Although, I heard good things about it.
Yeah, I mean, I didn't take the Net Plus as well. I went and did the CCNA directly, and it taught me the basic foundations of networking. So I would think that the CCNA will give you a stronger foundation in networking than the Net Plus.
Much better.
Now, William is asking, is there any advantage to put a network load balancer or application load balancer before the direct connect gateway? Now, why would you want to do this? So the direct connect gateway is aggregating connections from your VPCs, right? From the virtual private gateways and the VPCs. It's almost working like a load balancer in that sense. I mean, it's just aggregating the connections. So why do you want to place another device after it? Doesn't make any sense to me.
Yeah. Also, you can't place a network or an application load balancer. So application load balancer would make no sense because you're doing TLS termination on an application load balancer, so you're not really what you're looking for. Now with the network load balancer, that also wouldn't make sense because think of this as a private line, like from point A to point B. So really, there's no purpose. But Benedict did go through other methods to kind of aggregate links, like using link aggregation. Your connectivity provider can provide you with, can support MLAG as well if you want a more highly available setup. But yeah, definitely not a network or an application level. It's not possible, and I agree with Ben here.
Truth Factory. How does the billing work for Direct Connect? You pay two bills, one to the service provider and other to AWS for Direct Connect. That's why we said the VPN is cheaper, because you're leveraging the internet that is already existing in your organization. But the direct connection gives you better bandwidth, guaranteed bandwidth, better latency. So there's some trade-off here.
And Truth Factory is kind of interesting. So at least in America, if I buy a 10 gig link, I pay the monthly fee, and that's it. With AWS, it's a little different. You still have to pay for the 10 gig link. Then you have to pay a daily port fee because you have the link, and then you actually have to pay to use the link. So you can think of it that way, as it can be a lot more expensive connecting to the cloud than it would be if you just needed to connect two data centers together. Before we get to the next one, I should mention that if you've just joined us, we have almost 2 days of networking labs for you that you can download completely for free, do on your own time, on your own schedule, and we'd love you to. They have 2 kinds of labs in there. AWS labs, which will teach you how to configure things on AWS. And then we had one of our expert network architects do some labs in a data center environment on Cisco routers. And he walks people through the technology, how the technology is working at the underlying level, so you can truly learn it at a much deeper level than you could just by configuring. So please download them. They're in the chat box in the description of this video.
So Samson V says, Mike, I'm trying to understand your comments. Are you saying it is possible to have VPN links into direct connection location facility too?
No, what I was saying is that when you popped up something, I think it was a cut and paste graphic that we had that was sitting in our presentation from a network architect that was trying to demonstrate BGP as opposed to an AWS thing, and he read it with, you know, attention to detail and context.
Joseph, I'm a little lost on link aggregation for AWS. If AWS only supports 1 gig and 10 gig connections, that means that the organization can't achieve the 30 gig requirement.
Actually, go ahead, Benedict.
Okay, so I actually explained this, but let me re-explain. So it allows 10 gig connections, right? Now you need 30 gig connections. It means that you need 3 10 gig connections, right, into your organization. And then you use link aggregation to bundle those 3 10 gig connections to get your 30 gig requirements. That's what it means. Valerie, I knew someone would come up with an odd number.
Yep.
How would you get a 5 gig connection if you can aggregate only 4?
Well, actually, here's the way this is going to work, Valerie. What you're going to do is use as a direct connection partner, and you're going to buy a 10 gig link, and then you're going to rate limit it to 5 gigs, and that's how you're going to get a 5 gig link.
Mohammed, for active for public virtual interface, will load sharing between traffic? We're going to be load sharing between traffic, right? Not sure I fully understand.
Well, let me take an attempt at answering that. I think what he means is you have 2 public virtual interfaces, meaning going to an AWS resource, right? And so what he's asking is, can we load share between those 2, meaning send half of your traffic to the first link and the other half through the second link? I don't see anything that would stop us from doing that, right? Whether we split our advertised subnets so that half of them go this way and the other half goes the other way, or we're doing load sharing packet by packet. Because at least from your side, if you don't have any issues with asymmetric routing, then that shouldn't be an issue, because asymmetric routing here is pretty much might be unavoidable in this case. So yeah, it's doable, and there's nothing that would prevent you, unless you have a firewall, before your connection, which shouldn't be, but it's definitely
shouldn't be, but we've seen it.
Yeah. Yeah.
So William is asking, what's the relation between direct connection and cloud on ramp, if there's any? I'm not familiar with cloud on ramp, to be honest. Mo, have you come across that?
Yeah. So cloud on ramp, that's more of a SASE solution. Direct connect, that's a private line. I see where you would think that maybe there is there's some sort of a connection there, but there's not really. So both methods, so direct connect, you're running a private line, it goes through a co-location between AWS and the service integrators, right? Cloud on ramp is more of your SD-WAN at the edge routers, the SD-WAN edge routers would be able to based on the SD-WAN solution, what they would do is they have a list of, let's say you want to access Teams, right? You want to access Teams online. And what the service provider would do is that they maintain the fully qualified domain list for all those different applications, let's say, for example, Teams, and they would be able to send your traffic to the nearest point of presence for those applications. So it's really completely different technology from, I mean, unrelated to Direct Connect.
So Samson is asking, I might have missed this. To make two direct connect links truly a HA solution, wouldn't we need a second virtual private gateway for the VPC? So you're terminating the direct connect on your direct connect gateway, and you're terminating your from your VPC, you're terminating the virtual private gateway to the direct connect. So if you recall, when we spoke about VPN earlier, we said that the virtual private gateway is a highly available device, so it's redundant. So there's redundancy built into that part of the AWS solution.
So let's talk about that for a second. So Samson, have you ever worked with a router and you put a loopback address on the router because as long as the router is not dead, the loopback address is always up as opposed to like an Ethernet port? Well, when we deal with virtual devices, they could be on 1,000 different servers. So if a server goes down, they're not going to go down. So when we deal with our routers connecting to the cloud, we need very high availability devices because if they go down, we have a problem, and they can and will go down. But a logical device like a virtual private gateway goes down when the cloud goes down. Now the cloud can and will go down, but it only goes down when the cloud goes down. So that's why it's not really a weakness in the system.
Mohammed, can you explain to us how we manage the hybrid DNS connection in an organization with several accounts, and how VPC endpoints are managed in an organization with several accounts?
I mean, I do know we're going to be doing a lot more DNS coming up soon.
Yeah, we can take this question later.
Okay, so we're going to get back to the content so that we know that you're awake, alert, and oriented. If you can make sure to give us a hashtag AWS Advanced Networking. And that way we know you're here. The team will get back to the training. Hope you guys are having fun. I know I'm having fun. Okay, who is next?
It should be me.
I think that's you, Mo.
Yes. Okay. So we're doing a little bit more on direct connect gateways, private virtual interfaces, kind of like put things together just to drive. So, okay. So Pendleton explained what a direct connect gateway is, right? What it basically is a way for you to use private lines or a direct connect lines to establish a private dedicated connection from the data center, from your data center to your AWS cloud, right? Now, let's start by describing the solution itself, the gateway, right? The AWS Direct Connect Gateway is a globally available resource, which means that you can use the same Direct Connect Gateway to connect multiple VPCs from different from different regions, right? So that's one of the benefits. So for example, you can have one direct connect gateway that terminates a connection to your, let's say, your Asia Pacific or APAC data center, and then another connection that connects to your Americas data center, another one for EMEA's, and it can all be concentrated on that one direct connect connection, right? The direct connect gateway by default is not transitive, right? What I mean by that is that you have a direct connect gateway, and let's say you have multiple VPCs that connect to that direct connect gateway. Now, those VPCs can't talk to each other through direct connect, at least by default. There is a workaround, and I'll discuss that workaround. But by default, they can't talk to each other through that direct connect gateway. So it's non-transitive. The other thing is your data centers. Even though your data centers, we said you have an APAC and EMEA and America's data centers, right? Those data centers, they can't talk to each other through the direct connect gateway. But that also can be changed. And this is a newer update from AWS. I think they added it in 2022, where there's a new feature that allows you to connect multiple, or not to connect, but allow your data centers that are connected to the same direct connect gateway to talk to each other. Or even if you have two direct connect gateways and you pair them together, then you'll be able to allow those data centers to use AWS internal infrastructure to talk to each other, right? Okay, so we have three types of, actually, before I say this, let me backtrack and kind of do another quick review of direct connect. So this is one example. You have your data center here, right? And then over here you have your AWS cloud, and then you have this co-location facility. So AWS has its network racks and this co-location. Same thing for your connectivity provider, let's say AT&T or Megaport or whoever you're using, right? And then there is a meet me room. Let's think of it of the actual co-location, right? And then there's a cross connect that runs between those two providers, right? Between AWS and the connectivity providers, right? Now, the actual cable that runs between those two, we just call it a connection, right? So this actual cable that runs all the way here and then goes up here. Now, this is what we call a connection. Okay. So for connections, we have two types of connection. We have dedicated, if I can write dedicated, and then we have hosted, right? Imagine that this says hosted. So dedicated and hosted. What's the difference between dedicated and hosted? The simplest way to describe this is, think of dedicated as an actual dedicated line for you. So when they say it's layer 2, it's layer 2 end to end, right? And they maintain that for you, right? So it's not shared with anybody else. It's only for you. And there are some benefits to that. So let's discuss the dedicated first. So with dedicated, you have three options of bandwidth, right? You can have 1 10 or 100 gigs. And over that dedicated connection, this dedicated end-to-end is layer 2, and it's running 802.1q, meaning there's trunking. It's a trunk, right? So once you run that, then you can have up to 50 virtual interfaces. You can have up to 50 virtual interfaces over that connection. So what you can do once you have that connection is, let's say you would run a, let's say VLAN 10, VLAN 20, and 30, and so on and so forth, right? You can have multiple private, multiple virtual interfaces, and in each one of these interfaces is running over a specific 802.1q tag, right? So a different VLAN. So you get more control. This is more of a, if you want a more scalable design where you have a link and you know that you want to add more virtual interfaces in the future, that's one way you can do it, right? But it allows for speeds of 1 TB and 100. Okay. Another benefit of a dedicated circuit, because or a connection, because it is dedicated, you have the option of running layer 2 encryption, which is max security or MACsec, right? Max security, think of it as an encryption just like IPsec is encryption, but IPsec happens over layer 3, right? So it takes the header and everything before it and encrypts it. MACsec encrypts everything after the frame, so everything, right? So it just leaves the source and destination MAC address, and then it encrypts everything after, right? So that's something you can do with a dedicated connection. Now, with a dedicated connection, we said you can have up to 50 virtual interfaces, right? So in reality, you can have 50 public or private virtual interfaces, and we'll go through review what public and private means, but you can also have one transit virtual interface as well. So we'll talk about that as well. So this is a dedicated. Now hosted, you can have anything between 50 megabits per second to 10 gigabits per second. Now with hosted, because it's shared, meaning it's not solely used just by you, so the layer 2 link is done through layer 2 tunneling, and they guarantee you a bandwidth, but really it's in reality it is a shared connection through the co-location. You're sharing that connection here, and so because it's shared, because they're doing layer 2 tunneling on your behalf, so you can think of it as more of a virtual layer 2 link, and you cannot run max security over that. So layer 2 encryption is not an option. So if you wanted encryption, you would want to do something over layer 3, so layer 3 encryption. So the hosted connection can support private, transit, or public virtual interfaces, just like a dedicated. But you have less bandwidth options, and you can't run layer 2 encryption on top of it. Let me, okay. So let me share my screen. Give me 1 second. Okay. So a private virtual interface. What exactly is a private virtual interface, right? We said there's 3 types of virtual interfaces, right? So we established that connection, that line, as you see here, right? We established that actual connection, which is the physical connection end-to-end. Now over that connection, you want to run some sort of a peering between the direct connect gateway and the your on-premise router, right? So in order to do that, you have to choose which type of peering this is, right? Is it private? Is it public? or is it transit? Now with private, and I'll show you that, and I'll demonstrate it with a diagram. With a private VIF, this is a virtual interface or a VIF that only connects your on-premise to one virtual private cloud or one VPC. So if that's what you're looking for, if you want to connect only one VPC, then this is your option, right? So this would be, and I'll zoom in a little bit here. This would be option 1 and 2, actually. So those two options. If you look here, this is the co-location. This is your data center, and you want to run a private VIF. Notice that you have one that goes up here, and it's connected through, you see this symbol for a virtual gateway, so it connects to a virtual gateway. And then if you wanted to connect the other VPC as well, you would need to run a secondary line, right? Or a secondary virtual interface, right? But this means you need a new termination or a fiber optics cable, another cable that runs from your connectivity provider to you. So that means you're gonna have to pay the cost, for each installation. That's another physical line that terminates at your site. And of course, there's a lead time. If you want to get this, weeks, it could take months, right? So it's not very ideal, right? Just the fact that I need a new line for each connection is just not scalable. Another thing you can do, well, before we go there, now let's look at this connection using a direct connect gateway. So with a direct connect gateway, it's without, if it's still a private line, just as we had it, that means I'm still going to need a new private virtual interface for each VPC. So this peering, think of the virtual interface with this private virtual. Think of it as the actual BGP peering, right? When we said connection, hosted or dedicated, that's the actual cable. But when I say virtual interface, think of it as the actual BGP peering. So you would need to run multiple peers, one for each VPC with a private. And that's why it's called private, because it's only for one VPC. Now, if you wanted, let's say if I had 20 VPCs and I wanted those 20 VPCs to have access to on-premise through the same connection. This is where you would use a transit virtual interface, which is option 3 here. And now a transit virtual interface, as the name suggests, connects to a transit gateway. And once you connect to a transit gateway, that transit gateway can have access to 20 or 40 or 50 VPCs. That way those VPCs can share that virtual interface or transit virtual interface. So that's the benefit of the transit virtual interface. And then as you can see here, there's a lot of different setups you can do once you have this, right? Let's say you have another region and you have resources in a different region. You can set up a transit gateway peering, right? Yesterday we talked about transit gateways. You can have attachment to VPCs and you can have peering to peer with other transit gateways. And this is what you're doing here, right? So now you give your other account with different VPCs access to your resources, right? Now in this example, actually this is a very good example because you have some AWS resources like an S3 bucket, and through a transit gateway peering, you can give those your on-premise customers, you can give those customer or on-premise users, you can give them direct access through private access through this direct connect gateway to your AWS resources like S3, right? And you can do that by setting up an AWS private link, right? Okay, so using a private link, which we discussed yesterday, you give private access to your AWS resources through your direct connect or private link or private line. What if I wanted dedicated public access? Now, this might sound a little bit weird, but what if I still wanted to access my AWS resources publicly, but not through the public internet, meaning I wanted to reach those resources through public IP. So in that case, you would need to set up a public virtual interface. This is the third type. We said there's private virtual interfaces, there's transit virtual interface, and then there's public. Now with the public virtual interfaces, what you do is, and I'll use a different color to, what you do is you run another direct connect, right, from your on-premise, right, through to AWS. And when you run this, because this is public, what you do is the service provider, the AWS will advertise the public IPs of those resources. Let's say it's S3, they will be advertised through the direct connect. So establish and those resources will be advertised, right? So now when you have a default route through the internet to reach those resources versus a more specific public IP received through this public VIF peering, you'll obviously go through the more specific this way, right? For the S3 bucket, for those resources to reach you through the same direct connect, you have to make sure you also advertise your source IP, your public IPs this way. And that way, you'll be able to use the public VIF to reach those resources directly. As you can see, we have multiple options, right? This is more of a what I've seen in real life. People use this option. They use a transit VIF, and then they set up a private link, and then they advertise the route of the private link so that they can reach it through on-premise from this dedicated transit VIF. So those are the different types of, just wanted to give a visual representation of those different types of connections and virtual interfaces, right? Okay, a couple of points I want to bring up. One of them is, remember that it's not transitive by default, right? Which means one VPC can't talk to another VPC, okay? So this is one of the recent updates, and this has been the case since November 2021, right? This is more of something that we typically do in traditional networking, right? So since November 2021, AWS has started allowing customers to, let's say, adjust routing in a way where you can use the direct connect gateway as a transit resource or a transitive resource. And here's how it's done. If I go back here. So this is a good example I can use, or this diagram. If you remember from this diagram, right, we have multiple VPCs, and those different VPCs can use the direct connect gateway, right, to reach on-premise, right? imagine that there is behind this direct connect gateway, imagine that there's another VPC that's here, right? Let's call it VPC 4, okay? Because the direct connect gateway is not transitive, if you send traffic from VPC 4 to VPC 3, this is not going to work. The direct connect gateway will not allow you to send traffic this way. Even though both of these VPCs are behind the direct connect gateway, right? They can't talk to each other. Now, the new kind of workaround that AWS allows you to do now is you would, let's say this subnet is, you say if I can, okay, no. Let me write it down. Let's say this is 10.0.0.0/24. This is VPC 4, and VPC 3 is 10.0.0, or actually 10.0.1.0/24, right? So 10.0, 10.0.10 and 10.0.0.0, right? So you establish your transit virtual interface, and from the direct connect, you say that you're advertising those two subnets, right? You're advertising through BGP 10.0.0.0 and 10.0.1.0, right? And then from your side, you want to advertise your networks. Let's say you have a 172 network, a bunch of 172.16 network. So you're just going to advertise 172.16, let's say /24 or /20, let's say. This is your data center. Let's say it's a /20, right? Now, what you can do now is from your on-premise, if you advertise a supernet, let's say 10.0.0.0/23, right? /23 will account for the 00 and the 10, right? And then you would advertise it this way. Now, if you send your traffic from 10.0.0.0 all the way to the direct connect gateway, the direct connect gateway will still not send it this way, right? But what it will do is it will send it downstream. And once it's sent downstream here, this router will look around and see that it knows that 10.0.1.0 should be sent this way. So we'll send it back up to you. And then the direct connect gateway from this side, it will look at the actual more specific route and send it up here. Now, if you've been involved in networking at, at any capacity, this might trigger some of your spidey senses, and you will think, okay, this is a loop. This calls for a recursive loop where I send you a route, you send it back to me, right? But it doesn't, and the reason is the direct connect gateway doesn't act as a typical router, right? When you send the traffic this way, all it's looking at is the more specific route. It doesn't see this side, right? So because it's non-transitive by nature, right, it can never send the traffic this way. So think of this as a separate routing table pointing to VPC4 from the routing table pointing to VPC3. But this is just shared routing table from this side. So when you send traffic this way, it can only see the longer subnet, the supernet. So it can send it downstream. But this router knows that it doesn't own it doesn't own anything outside of 172.16, but it's seeing that it received those two advertisement, the 10 and the 00, the longer prefixes. So we'll just send it back, right? And then when it's sent here, this is a different routing table from this one and this one. So in this routing table, this direct connect gateway knows to reach 10.0.10 this way, right? Now for this to work on your on-premise router, you have to make sure that unicast RBF is disabled. Because with unicast RBF, you would not receive routes, right? Basically, it's a loop prevention mechanism for unicast traffic. And it also helps against attacks where somebody would source traffic from a source that is not intended, that shouldn't be intended to you. So you got to make sure that unicast RBF is enabled pretty much. Okay. Yeah, that's everything. So benefits of the direct connect gateway. Well, it can obviously performance, right? Number one, the biggest thing is performance, right? So while the internet is best effort, right? Even though you have a bandwidth, guaranteed bandwidth maybe from your service provider, but they can't really guarantee your traffic will reach point A to point B without some traffic being dropped. So the quality is really, it's not guaranteed, right? Because it's public. It's a shared infrastructure, the internet. So you obviously get a consistent performance because that's a private line dedicated to you, right? The second thing is enhanced security, right? Because it's a dedicated line, right? There's less risk of dealing with any sort of man-in-the-middle attack or some bad actor getting having access to your data and just storing that data, right? There's, aside from regulations and laws, right, there's nothing stopping a service provider from logging all your traffic, right? Mirroring all your traffic, and then they can just, hold it in a storage facility and, try to, decrypt your traffic, right? So, you get that enhanced security, right? Or added security. And so one other thing, and this is strictly a benefit of a direct connect gateway, because you can still have private lines without a direct connect gateway, right? The benefit of a direct connect gateway is that it can reduce the cost because of instead of running multiple private lines and having to pay for multiple private lines, you could potentially use one private line and share that line across many VPCs, right? And you can use one connection and use that same connection to establish multiple virtual interfaces, right? Up to 50, as we described previously. So there's obviously that added benefit of using a direct connect gateway versus just running private lines straight to your VPC. Okay. Any questions?
Welcome back, everyone. We are here to take some questions, and then we'll get into some DNS. But let's get to some questions first. From Muhammad. I'll read it. You guys can answer this. Direct connect gateway would help connect to co-location using virtual interfaces. I think that's a question.
Yes. Yeah. That's an accurate statement. So direct connect gateway will help you connect to co-locations. Well, help when connecting to co-location using a virtual interface. Yes. So yeah, the co-location will establish that line that terminates at your data center, right? That's what we call a connection. And then you run a virtual interface on top of that. Yes. I think that would be an accurate statement. How would you connect two organizations other than VPN? I'm not talking about connections of account under the same organization. Okay, so you have two organizations, right? So I'm guessing you mean an organization is in two different companies running on AWS, but they're completely different organizations, because there's a meaning of the word organization inside AWS. So I'm assuming it's two different companies, right? They're running two different organizations, two different accounts, and you want to connect those two companies to each other. You want something other than VPNs. Well, as we described previously, you have you can use a VPC peering, but do you trust the organization, right? So with that, do you trust them to run VPC peering between you and that organization, right? VPN might be one of your better options, but VPC peering is an option. Transit gateways, you can give them a transit gateway attachment, share your transit gateway as a resource, give them an attachment, and then they can use that attachment. And if you want to add an extra layer of protection, you can set up an east-west encryption, east-west inspection, so that their traffic is inspected before it can see the rest of your VPCs. But yeah, that would be another option. I wouldn't say using direct connect in this example. It's not a practical option to have direct connect.
If they're both on the same cloud.
Yeah.
Okay, so Samsung, and I'll get it. I'll actually do this, and I'll whiteboard it out with you. So a trunk really means that you're carrying multiple somethings on a single wire. So in voice trunking, we might have multiple lines go out a port to the phone provider from the phone switch. And in network trunking, we're actually talking about trunking VLANs. I'll draw this out for you. I know we did it on the first day, and that's okay. It's a pretty important concept that you need to know for a lot of things, so let's draw it out. Bear with me while I set up my screen. I will draw this out, and then we'll get back to answering questions, so bear with me. So let me do this. Oops, over here. We'll go to scene 2. Okay, great. So here we're on my fancy whiteboard over here. And what we're going to do is we're going to take a switch. This is where VLANs come from. So we're going to consider the box to be a switch. And then what we're ultimately going to do is put some ports on the switch, because switches basically have a lot of ports where you'd plug your routers into the switches. If we were dealing with classic routers, you'd plug your servers into the switches. Bear with me. Okay, so now we put some ports on this switch. Now let's populate this switch with ports. And I'll show you the two alternatives we would actually have to provide two sets of connectivity. So in this case, we're going to connect switch to switch, but we could have also connected to the cloud provider. It's realistically the same thing. Let's say, for example, we want these top 10 switch ports to be isolated from every other port in this switch, because by default, all switches are on a VLAN, which means a broadcast domain, and every port in a switch can technically talk to every other port, unless we virtualize that switch by chopping it up into mini switches called VLANs. So in this particular case, we've got the top 10 ports that can only talk to each other, the next 10 ports that can only talk to each other, because we're going to create 4 VLANs here, the next 10 ports which can only talk to each other, and another 10 ports that can only talk to each other. So we've separated everybody into 4 different categories. Now, let's say on the left side of this, which is the cloud provider, or it's the switch, it really doesn't matter, the point is the same. We decide to create these 10 ports, and only they can talk to each other. And then only these 10 ports can talk to each other. And then only these ports can talk to each other. And now only these last 10 ports can talk to each other. So now each switch, the top ports can only talk to each other. The medium ports on each switch can only talk to each other. The lower, the penultimate ports on the closer to the bottom can only talk to each other. And the bottom ports can only talk to each other. What if we wanted the top ports to talk to the top ports? We'd have 2 options. We could run a cable from the top ports to the top ports, and then those 10 could talk to each other. We could then run another cable for these these ports to talk to each other, and another cable for these ports to talk to each other, and then another cable, and then we'd have the equivalent of 4 VLANs. Or we'd be letting those 4 systems talk to each other. By comparison, a trunk port does something a little different. We create a single cable or a single piece of fiber between the ports, between the 2 switches, and then we tell the switches that they can send all the information off of all those 4 individualized virtual LANs all on the single cable. And what happens is how this works is when we take a frame from this particular VLAN, we actually put something called the tag on it. And typically speaking, it's going to be an 802.1q tag. And when the frame goes on this wire, they put the tag goes placed off. The tag stays on this wire, and as soon as it leaves the wire, the tag is stripped off, and the frame goes exactly where it was supposed to. So when we use a direct connection, what we're really dealing with is a VLAN, because we send them a VLAN, and that VLAN goes on the wire, and we give them an 802.1q trunk to segregate the traffic. And that is technically a form of VPN. It's a layer 2 VPN. Chris, we can all come back on the screen. I just thought that would help for Samsung.
Can you say that a direct connect company uses VXLAN to separate the various shared mediums? Or how do they separate the bandwidth? Well, I would say it's probably some sort of, it's definitely, okay, let me say this. It's definitely not just 802.1q, right? It has to be some sort of, so it could be VXLAN, but there's a lot of different methods to do this, right? So yeah, more likely not. Well, there's a high probability it's VXLAN. I'm trying to say yes, but that's not public information that, and I've asked. Trust me, I've asked different service connectivity providers, and that's not information they disclose. Can we have 2 direct connect gateways in 2 separate regions? And how would you connect through one transit VIF? So yes, you can. What you're trying to do here is have 2 separate direct connect gateways, right? And then each you want to peer between those 2 direct connect gateways, right? But then you want traffic. So what you're trying to establish here, this is not how you would do it. No, but I'm thinking that this is what you mean. But if you have 2 direct connect gateways, right, 2 different regions, right, and you have 2 data centers, right, and you want those 2 data centers. Actually, if you don't mind, can I whiteboard this real quick?
Yeah, go ahead. Good idea.
Okay. I think this is a very good question.
One needs to share a screen.
Okay. Okay, I'll start sharing my screen. Now, use slides. Okay. So let's say you have one direct connect gateway here, another direct connect gateway here, right? Let's say this is US East 1, right? Let's say this is US West, some other region, right? And then over here, you have a private line going to one data center. Let's call this data center 1. Okay. Well, can you have a connection between those direct connect gateways? Yes, you can. Right. And of course, you have multiple VPCs. Let's say here you have multiple VPCs, right? But for this scenario, let's assume you have one VPC each, right? Now, you can obviously, you can talk, this VPC can talk to on-premise and vice versa. Same thing for this side, right? Can this VPC talk to this VPC? No, this is not possible, right? This is where you would use something like a transit gateway, right? So maybe you have a transit gateway in this region, right? And a transit gateway in this region. You connect those transit gateways to each other. That's how you would set something like that up, right? Which means your direct connect gateway doesn't connect directly to your VPCs, but it connects to a transit gateway first. Because with a transit gateway, otherwise you would need multiple virtual interfaces. You're going to end up paying for more, right? So usually you would have a transit gateway, and then all your VPCs connect to that transit gateway, and the transit gateway connect to the direct connect. In that scenario, then, if you wanted VPCs in one region to talk to VPCs in another region, it would make sense to just run a peering between those transit gateways. Okay. Now, your question may have been, how about, because I'm answering two questions, right? So that was answering question one. How about connections between data center 1 and data center 2? Well, by default, this is not available. But as of 2022, AWS introduced a new feature where data center 1 can talk to data center 2 using AWS private infrastructure. So instead of going and buying a DCI or data center interconnect line, right, between your data, you can use AWS as your DCI, right, and then end up using AWS private infrastructure to run from direct connect your gateway 1 to direct connect gateway 2 all the way to your data center. So that's possible, but obviously it comes at a cost, right? So you got to keep that in mind as well. Hope that answers your question.
Okay. Are there any others? Oh. How many backups should we have when creating a database for a client? Okay, so the business requirements are going to drive this. How many databases does a client have? It may have 5 different databases. What is the value of the data for that organization? What is the risk if that data is compromised or lost for that organization? What is the likelihood of risk for that organization? We can take these things and a whole lot other questions, and then we can analyze that information and we can make a determination. But it's not something we're going to get very simply or very quickly. It's not like we can say 1 or 2 or 10. It's going to be highly dependent on the mission.
Okay. Would this work around the SuperNet to Direct Connect gateway have a higher latency as the traffic goes to the office location before being directed back to the other VPC? Yeah, it definitely would have a higher latency than having, VPCs connected through a transit gateway or peering transit gateways together, right? But it's still, and you end up using your direct connect link or private link for traffic that is not intended from on-premise to cloud. So it's really, I don't see a lot of use cases for this unless you're limited with your current design. For example, you have an existing design where you don't have a transit gateway and everything is connected through the direct connect. And then it's kind of like, an option that's available. But if you were to set this up properly, you probably want to use a transit gateway and then peer everything through the transit gateway. Mike, you are muted. I'm not sure if it's you.
Mike, you muted yourself somehow.
Go figure. So no, these slides are internal and personal to us. We each make slides not for the point of sharing them, This content is available for sharing, and you can go watch it free. And we have some free ebooks that you can get as well, and attend a lot of free webinars. But these slides, personally, I have only 4 words per slide on the majority of my slides. Just reminds me to go talk about something. Benedict's slides are personal to him that he's created, and most slides are personal to them. We only put down on slides what we truly need to be able to remind us to deliver what we need. We're not in the business of doing what's called death by PowerPoint, where we read PowerPoint slides for you that are written word for word. We're really here about trying to make you have a good education. So watch these videos as many times as you like. Come to some free webinars and learn. And we're not going anywhere. We've got lots of opportunities for you to be able to ask questions and learn more. So the next question, the challenge, though, that a single direct link is a single point of failure. Absolutely true. Any single link is a single point of failure. So maybe you need more than one direct connection based upon your bandwidth needs. Maybe you can do a direct connection with the VPN backup. But absolutely, anything is a single point of failure, including a single cloud, no matter how many availability zones and regions you use. And here's why. It's all on a common network. So if a single cloud gets hacked, it goes down. If the network were to collapse, the whole cloud goes down. If the cloud's control plane goes down, it's a single, and that can take the cloud down, the whole cloud. So, yep, single point of failure.
Okay, so second question, I can answer that one if you want. So, is there a one-to-one relationship between VPCs and virtual interfaces, right? Meaning, if there are 10 VPCs, we need to connect 10 virtual interfaces. It depends. It depends on the type of virtual interface you're using. If you're using a private virtual interface, then yes, that's a one-to-one. But if you use a transit virtual interface, then no, you can use that transit virtual interface to connect to a transit gateway. And then behind that transit gateway, you can have as many VPCs as the transit gateway allows you or permits. These updates from AWS, are they implemented through the CLI, or do we need to redeploy a new script for an infrastructure with a transitive connection? I'm not sure what you mean here. Does anybody understand the question?
I'm not actually sure at all. What he means, which updates?
Yeah. Oh. I don't know. I really I'm not sure what you mean by this question.
Why don't you ask that question on Slack, Valerie, and we'll happily answer it, since you might be limited with what you're able to say and we don't understand it.
If I get a 9 gig, no.
If you get a 9 gig rate limit on a 10 gig direct connection, do you get billed for 9 or 10? Well, you're going to pay for the link to the cloud, to the provider is still going to be 10 gigs. You're not going to pay for the full 10 gigs. But, you know, if you're going to rate limit at 9 Samsung, it's going to get real funny, because the maximum throughput on a 10 gig link is about 9 gigs when you account for headers. So that's an interesting one. I don't think you'll be saving much at that point. And actually, you'll probably pay for more, because here's the way the business model works on these direct connection partners. They charge you a higher rate per data than you would normally charge, because they're giving you fractional data. So you would probably pay more for 9 gigs on that 10 gig link to be rate limited than you would by getting the 10 gig link directly straight from the provider. What's the difference between bandwidth and speed? There really is technically no such thing as bandwidth. It's technically the speed. You know, we started coming with baseband and broadband, and a lot of that had to do with the frequencies that we were actually changing, that we were sending the data, and then it got colloquially termed, oh, the bandwidth, you have the speed, but it wasn't technically the bandwidth.
Okay, so this is the second part of the question mark. And then after he's asking the difference between bandwidth and speed, I am asking if this, as AWS asks for the speed every time, and it confuses me what to say.
I would say the speed, and the speed is going to be in bits per second, megabits per second, gigabits per second. It's always going to be the speed.
Usually, for example, on let's say network devices, you see both speed and bandwidth. Usually, a speed is the actual speed, the rate limit of the interface, but the bandwidth is really more of a software. Think of it if it's something for different routing protocols to use. Different routing protocols use it differently, but it doesn't actually affect the speed of the link
No.
when you put the bandwidth command, for example, on the CLI of a router. But the speed definitely does affect it. That's the actual physical speed.
And say what Mo's actually referring to here is on your routers, they have the ability to calculate the speed and determine the best path through the network. And it's actually the speed of the link. A 10 gig link is 10 gigs. But one of the software developers at Cisco thought that it would be fun to use the bandwidth command. So you can modify the link speed by telling it the bandwidth, and the routers would know how to calculate that bandwidth software command that somebody put in there and consider it to be the speed, but it wasn't actually the speed of the link. That's a good point, Mo. Folks, get some additional books and materials for study. Yep, that's exactly what we said in the beginning. Never rely on one source. When you were preparing for your first CISSP back in 2006, you used 10 books to prepare. Knowledge is power. Completely agree. Now, the reality is there's not a lot of good books on the AWS Advanced Networking, but we referred you to the most authoritative sources. We referred you to the IEEE for the Ethernet specifications. We referred you to the Internet Engineering Task Force, and we refer you to the AWS documentation, which is the source of the material. That's where you go. You get your highest and best rated things. So we strongly, strongly agree. And every time we teach a course, we always talk about our books. We recommended the Stevens TCP/IP book. We recommended the Internet Routing Architectures book at the beginning of this course from Bassam Halabi. We recommended Routing TCP/IP volumes 1 and 2 from Jeff Doyle. And absolutely, completely agree. We're architects. I've read hundreds of, actually I read thousands of books in my careers, and I think it's a great thing. Read, and learn, and try to get better every day. Completely agree.
Does the transit gateway connection goes through an ISP before reaching another region? No, it does not go through an ISP, because if you have a connection between two transit gateways, this is using AWS global infrastructure, and they have a global infrastructure. They use it for many different services. And so this will be a private connection from one transit gateway to another transit gateway.
One more question, and then I am up, and then I'll go for a little bit, and then at some point I think we break for lunch, and then we come back.
Okay. So I can summarize this question. I read it briefly. So basically, if you're using a VPC endpoint, right? And usually VPC endpoint, you point it to a service. What Samson is asking, can I use that same VPC endpoint or VPC interface endpoint and for multiple services, not just for one? And the answer is no. The VPC endpoint and interface endpoint is only for one service. So if you wanted one for just like you said, you wanted one for a Lambda function, another one for an S3, then you would need two VPC interface endpoints, one for each.
All right. Well, you know what? Let's do some DNS. I will start the DNS, then we'll go to lunch, and then the rest of the team will do some more DNS stuff with you, which is, to me, is kind of great. Kind of fun. Anytime we talk about anything network related, I become pretty happy. Okay, so now let's talk about DNS and Route 53. So, DNS, what's the point? The domain name system was designed to make it easy for us to remember how to reach things. See, every device on the internet needs an IP address. And it's totally possible, if you've got the memory to just pop an IP address into a web browser to connect to a website, for example. It's totally possible on a server, if you're trying to map a network drive to a server, to put the IP address of the server versus the server name, and it's going to work. The problem is, how do you remember all those names? And that's where things get on the fairly complicated side. So if you wanted to figure out how to go to Amazon.com, you could remember their IP address, or, and here's the or, you can type www.amazon.com into your browser. And DNS, or the domain name system, could then translate the IP address, which is really what you're trying to connect to a user-friendly name called Amazon.com. And that's really what we're talking about here. So the whole point is to map a name to an IP address. So I'm going to give you guys a little hands-on thing to play with real quick. Think we'll have fun with it. And then after that, we'll start talking. So I would like all of you on your computers, if you're on a computer, if you're on Windows, get me a command prompt. If you're on a Mac or a Linux system, get me a terminal window. And in that terminal window, I want you to type something. I want you to type www. I'm sorry, don't type that. Type NS lookup, NS November Sierra, L Lima, O Oscar, K Kilo, U Uniform, P Papa. So NS lookup, and then type www.amazon.com and hit enter. And you know what you're going to see? You're going to actually find the IP address, or at least the content delivery network's IP address for Amazon.com. I'll do it as well. And the IP address that I'm getting for my local CloudFront distribution, and we'll get into content delivery networks, is 18.161.75.84. And they could be using various flavors of DNS routing, but that's the IP address that I get when I do an NS lookup for Amazon.com. And it's a lot easier to remember that than it is the actual Amazon.com than it actually is that. So if a domain name maps something friendly to an IP address, what goes into this? Well, there's actually three parts of your domain name. The host name, which is the name of the system, the domain name itself, and then the top level domain. So a host name could be Mike EC2. The domain name would be gocloudcareers.com. Would be gocloudcareers, and the top level domain would be .com. So if we're dealing with a web context, the fully qualified domain name might be www. The domain name might be gocloudcareers, and the top level domain may be .com. And of course, other top level domains like .edu, .co, .uk, .gr for Greece, like where I'm from. And that's really what we're talking about when we talk about the domain name. The host name, the domain name itself, and then the top level domain. And that's what we call a fully qualified domain name. And a computer and a DNS system can resolve a fully qualified domain name for you. Now you can also create a subdomain. For example, you could buy gocloudcareers.com, and I can have a subdomain called training.gocloudcareers.com. It's called the subdomain. And many times organizations buy a domain and they create little mini subdomains inside of their domain. So that's something you can deal with to just put it into context. So now let's talk a little bit about top level domains. The top level domain is the highest part of the domain thing that you're going to hear about. And that's typically where you hear something that ends in .com for US sites, or .net, or .edu, or .co, or .uk. Now, where's the control of these top-level domains? They're typically controlled by ICANN, which is an acronym for the Internet Corporation for Assigned Names and Numbers. So, global organization. And they typically own the assigning of the names. Now, the top-level domains are going to be the second highest level of DNS, because DNS is hierarchical. And all of this, of course, comes under the root domain. And then the root domain will be the overarching structure that contains all of the subdomains and every single folder that would belong to, say, a website. Now, lots of top-level domains used today, more of them coming. Even .aws is a top-level domain. So top-level domain servers are going to be groups of servers that are going to facilitate the generation of websites' IP addresses. So hopefully that kind of explains some of it. Now, when we talk about DNS, we also have the concept of a DNS zone. DNS is going to be broken up into multiple zones, and these zones are going to be managed separately in the DNS namespace. And they're going to be managed, of course, by different entities. And by dealing with it this way, it's going to allow for simple and more authoritative and more fine-grained control of all the components of the DNS. And this doesn't mean that zones necessarily have to be geographically isolated. It means they are logically separated to separate degrees of control itself. And this is going to tie into the fact that the domain namespace is going to be a hierarchical system with the root domain situated at the top. So I typically look at it like this. I see these, you've got your root domain, and then your first level domain, and then your second level domain, and then your third. So here you've got your DNS, and then your first level domains are your .com, .net, .edu, and then your second level domain could be .google. And then Google has these subdomains, drive.google.com, mail.google.com, etc. So that's typically what you're dealing with. Now, we're going to get involved in the domain registry and domain registrars and domain registrants. You may see these kind of questions pop up. Kind of important to understand it anyway. So what is the domain registry? The domain registry is really just a database that contains all the DNS names and all of the associated information from the top-level domains. And, you know, there are organizations that manage these top-level domains. For example, VeriSign manages all the .com domain names. And these organizations are all under the umbrella of, you know, ICANN, the Internet Corporation for Assigned Names and Numbers, which is a nonprofit organization to kind of manage all the vital DNS resources. And ICANN will also create a policy and define a policy of how the names and numbers of the internet should run, and has to some degree centralized control of the DNS system. So that's domain registry. Now, who is the domain registrar? When you want to go buy a domain, you go to a domain registrar. GoDaddy is a domain registrar. You go to Amazon and you can buy Route 53, buy a domain from Route 53. And then, so they're going to be the domain name registrars. They will handle the reservation of domain names and mapping them to IP addresses. And they don't actually manage or maintain the domain name. They act as a vehicle for the end user to use their domain name. And then, of course, there's the domain registrant. The registrant is the person who purchases the domain and uses the domain. Usually it's a corporation or an individual or anybody that has the ability to want to buy and use the domain. Registry at the top. Registrar is the people that sell it to you, like GoDaddy or AWS, and registrant, the actual user. So hopefully this makes a little more sense graphically. At the top, you've got that domain registry. Then you've got your domain registrars that you purchase from, like GoDaddy or AWS. There's lots of companies that resell the domain. And then the registrant is the actual user. So I think we timed this almost kind of perfectly. We have the next component of what we're actually dealing with here is going to be the DNS record types. And we're going to get pretty heavy into this, and it's very important information as you plan on you routing your information back and forth, your failover policies, your performance policies, you know, potentially red, green, blue, green deployments, and so many other things. So I think this is a natural point to break. Right after lunch, we will get involved into the DNS record types, and from there, we'll have a lot more content to cover today. So we'll begin again at exactly 2 p.m. Give me a hashtag AWS Advanced Networking. If you enjoyed the videos from lessons this morning, please give it a like. If you're not a subscriber, please subscribe and hit the bell to be notified of new videos. And of course, get your free labs. We have almost 2 days worth of labs. We have about a day and a quarter right now, but behind the scenes, one of my CCIEs is creating a lot of networking content for you guys to learn networking, more networking. So go download it. They'll be available and they'll keep getting updated. We'll see you back in 1 hour at exactly 2 p.m. Eastern Time.